You send a broadcast frame on a switch. Every device in the office hears it. Even HR. Imagine 3 departments: engineering, HR, and sales, all connected to one switch. All in VLAN 1, all in the same broadcast domain. When engineering sends a broadcast, HR's server sees it. Sales sees it. Everyone sees it. From a security standpoint, that is a problem. From a performance standpoint, it is worse. Subnetting at layer 3 helps. You can force inter-department traffic through a router and apply access controls. But switches are not layer 3 aware. They still flood broadcasts to every port. So you need layer 2 segmentation. That is where VLANs come in. A VLAN, virtual LAN, divides one physical switch into multiple virtual switches. Each VLAN is its own broadcast domain. Frames from VLAN 10 never reach VLAN 20. The physical network stays the same, but the switch now behaves like 3 separate switches. And here is the rule CCNA wants you to remember. 1 VLAN per subnet. 1-to-1. Now let's configure them. By default, every port on a Cisco switch is in VLAN 1, the default VLAN. You can change that. First, create the VLANs. In global configuration mode, use the command VLAN 10, then name it with name engineering. Do the same for VLAN 20 and VLAN 30. Next, assign ports. Go into interface configuration mode. Set the port to access mode with switch port mode access. Then assign it to a VLAN with switch port access VLAN 10. That is it. The switch now forwards frames within each VLAN, but never between them. But what if you have 2 switches, and hosts in the same VLAN are connected to different switches? You need a trunk port. A trunk port carries traffic for multiple VLANs. It does this by tagging frames with an 802.1q header, 4 bytes inserted between the source MAC and the ether type field. The 802.1q tag has 2 main fields. TPID, the tag protocol identifier, is always 0. That is how the switch knows the frame is tagged. Then TCI, the tag control information, contains the VID, the VLAN identifier. 12 bits. That gives you 4,096 possible VLANs. To configure a trunk, use switch port mode trunk. If your switch supports both 802.1q and ISL, the old Cisco proprietary protocol, you must first set the encapsulation with switch port trunk encapsulation .1q. By default, all VLANs are allowed on a trunk. Best practice is to restrict it. Switch port trunk allowed VLAN 10, 20, 30. And here's a mistake that costs people on the exam. If you want to add VLAN 40, do not use switch port trunk allowed VLAN 40. That replaces the entire list with only VLAN 40. You must use the add keyword. Switch port trunk allowed VLAN add 40. Now, the native VLAN. The native VLAN is the VLAN whose frames are sent untagged on a trunk. By default, it is VLAN 1. If a switch receives an untagged frame on a trunk port, it assigns it to the native VLAN. If the native VLAN mismatches on both ends of a trunk, VLAN 10 on one side, VLAN 30 on the other, frames cross VLAN boundaries silently. That is called VLAN hopping, and it is a security risk. Best practice: change the native VLAN to an unused VLAN. Something like VLAN 999. Configure it with switch port trunk native VLAN 999. And here is an exam tip. The default VLAN and the native VLAN are not the same thing. The default VLAN is VLAN 1. It cannot be changed. Eine Strickfehnel. Gobrich Wings amplifiers. The native VLAN is also VLAN 1 by default. but you can change it per port. Now, hosts in different VLANs need to communicate. That requires routing, Inter-VLAN routing. The first method is router on a stick. You connect the switch to the router with a single trunk link, then create subinterfaces on the router. Each subinterface handles one VLAN. On the router, create interface G0/0.10, set encapsulation .1Q10, and assign an IP address. That subinterface becomes the default gateway for VLAN 10. Repeat for VLANs 20 and 30. One physical cable, multiple VLANs. Router on a stick. But the most common method is a multi-layer switch, also called a layer 3 switch. Instead of subinterfaces on a router, you create SVIs, switch virtual interfaces, on the switch itself. Enable IP routing with the command IP routing. Then create interface VLAN 10 and assign an IP address. That SVI is the default gateway for VLAN 10. For an SVI to come up, 4 things must be true. The VLAN must exist, there must be an active access port or trunk allowing that VLAN, the VLAN must not be shut down, and the SVI itself must not be shut down. And if you need external connectivity from a multi-layer switch, convert a physical port to a routed port with no switch port. Assign an IP address, and configure a default route. That is VLANs. Layer 2 segmentation. Trunking with 802.11q. Inter-VLAN routing with router on a stick or multi-layer switches. On the Ccna exam, expect questions about native VLAN mismatch, trunk-allowed VLAN keywords, SVI requirements, and the difference between default VLAN and native VLAN.